top and bottom by 1 over n squared, or you can just use, I call it the degree argument. And they're the same degree, it's the quotient of the lead coefficients. Do we all agree that this is 2/3 without doing any work? Yeah, you can do L'Hopital's rule twice. You never do L'Hopital's rules on limits to infinity. That's inefficient. And by the way, if you're tempted to use L'Hopital's rule, then I'll throw some zeros on the exponent. No, this is not a L'Hopital problem at all. It's legal. It's the longest possible route you could take. No, same degree, lead coefficients. Now, do I need to do much else? Here's what I'm going to write. And this is not 0. Therefore, diverges. I want you to get used to the following. We're going to learn 5 different tests over the next couple of weeks. To say converges or diverges, you always want to indicate what test you did, and there's many reasons for that. But what did it fail? I said, generically, we call this the nth term test. So it diverges by the nth term test. We're going to have 2 different comparison tests. We're going to have a ratio test, we're going to have a root test, we're going to have an integral test. And part of the reason you always want to state the reason, and this is for the future, you're going to be taking limits almost every time. In every problem, you're going to be taking limits. Sometimes a limit of 1 is a great limit because of the test you did. Sometimes a limit of 1 is the worst possible limit because of the test you did. It's the most ambiguous answer. Sometimes the limit's infinity, which would be a great limit. Other times the limit's infinity, which is a terrible limit, depending on the test you did. So just getting a value for a limit doesn't tell you anything. It depends on which test you did. So that's why you always want to indicate the test, because otherwise it actually will happen that you did the limit correctly but made the wrong conclusion because of the test you performed. So you always want to indicate, so we just did the nth term test and it failed. That's the only one we know right now. That was good enough. We cannot, by the way, we cannot conclude convergence yet. We don't know what the rules for convergence are, but we definitely can conclude divergence right now. Okay? Everybody okay with that? All right. Let's do another one. Okay, there's still time to change major, one for the hills. Or maybe it's not that bad. I don't know. What do you think? As a whole, I can't really do much with that. I definitely don't want to take the limit of that thing. Well, I don't want to take the limit of that because numerator and denominator both grow without bound, and I could use L'Hopital's rule, but how many times would I have to do it?
The basic number.
Infinitely many, yeah. So that won't help me either. How about if I do something like this?
Yeah.
Can I do that?
Yeah.
2n over 4n plus 3n over 4n.
Okay, let's start with that.
Okay.
Okay. Can I do that? Didn't we just prove we can do that a few minutes ago? That's why we proved it, because of a problem like this. So what if I did this? And I'm not going to do any algebra yet. True or false?
True.
The summation of a sum is the sum of the summations. That still doesn't look like anything yet. How about if I rewrite this one? Is that true? That's an exponent property. Is that true?
Yeah.
Why would I do such a thing? Because now they clearly look like geometric series. Ooh. And by the way, that's my R right there. The first one 2/4, second one 3/4. Because I'm starting at 1, that's also the first term, isn't it? Because when n equals 1, I have 2/4. I don't care if you write 1/2.
They're both less than 1.
It's less than 1/2 the value. So are both of these pieces going to converge?
Yes.
Yes. So the first one, let me just write it down. My first term is 2/4 and my R is 2/4, correct? Because I don't have anything in front of it, so it's just 2/4 to the first power. How about the second one? My first term is 3/4, and my r is 3/4, again, because I don't have any coefficient in front. So can I say this sum is 2/4 over 1 minus 2/4 plus 3/4 over 1 minus 3/4? Can I say that without doing anything else? Yes, no, maybe?
Yes.
Yeah, remember, we derived this. You don't have to ever re-derive it. You just have to recognize when to use it and now use it successfully. First term over 1 minus r. So what is this?
1.
1, and what's this?
Oh, that one.
3 over
Just 3.
4.
Whoa, that is so cool. You like that?
No.
That's kind of cool. We could do that. Oh, let's try another one. We're really good at this now. All right. I'll do a similar problem. This was the original question. We just used simple algebra and we got it to here. Do you think we could fast forward? You want to try? Just make sure you don't mess it up. Here's what I'm asking you to do. Can you do this? In fact, here's what. Can you do that? Can you go directly there? Yeah, we just did. I mean, I just showed you the route. This problem does not come up that often. Don't memorize what we just did.
No.
Just understand. I'm asking you an almost identical question. The algebra we performed is going to be the same algebra. So let's take advantage of that. So this is going to be what? 2/3 to the end, and this is going to be minus 4/3 to the end. All right, cool. So this is pretty easy. This one's pretty easy. That's going to be really simple. So I'm going to spend some time figuring out that sum, right?
The second term diverges.
But the second term diverges. Why?
Because the absolute value is 4/3 bigger.
Why do you use it? Yeah. Oh, this diverges. Does it matter what the first term converges to? Nope. Does not matter what the first term converges to, this diverges. Now, is it going to diverge without limit? Is it going to diverge infinitely? How do you think it's going to diverge? Yeah, and because that negative is in front, this would actually be negative infinity. But we care more that it diverges. And I want you guys to understand that. If you can tell me it diverges to negative infinity, wow, that's awesome. But you know what? I just care that it diverges. It doesn't converge. This converged, therefore you continued and told me what it converged to. This doesn't converge, therefore we can't use this to answer any real questions because it doesn't converge to a specific value. That I know that at first I go, wait a minute, but don't we need to know? It's about it converges or it doesn't. There's two forms of divergence, and when I'm just finding a limit, yes, I'm interested in that. But I'm asking you, does the sum converge? If it does, give me a value. If it doesn't, tell me it doesn't and tell me why. This diverges as a geometric series because the r is bigger than 1. And that's it. That's all you need to say. Again, if you want to get really strict, it's going to diverge to negative infinity because you have finite number minus infinity, technically. Okay? You good so far? That's just not the worst thing, is it? There are worse things. I think we did one like this last day. I mean, you can certainly get out your calculator, cos 1 plus cos 2 plus cos 3 plus cos 4. What do you think?
0.
What, didn't we do something similar last day? We looked at the sequence. You had cos 1, cos 2, cos 3, cos 4. We did a few numbers, and you found a few numbers were positive, then a few numbers were negative, and usually it's like 3 in a row positive, 3 in a row negative.
Right.
But you never saw the same numbers, did you?
No.
Because I'm inputting integer values, not multiples of pi. So here's the first question. Tell me about this limit.
Well,
We did this last day. We know what this limit is. It's DNE.
Right.
But more importantly, it's not 0.
no.
It never, in fact, it just keeps bouncing.
Right.
Positive, 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 negative, 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 positive, 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 negative, negative. It never gets close to
Yeah.
0, really. So
Diverges without limit?
this limit does not exist. So this sum would diverge without limit. That's a great answer. I'm good enough with divergent. But everybody understand? It diverges without limit because they don't approach anything. So this diverges, but why? Because it failed the nth term test. Okay.
Oh.
Ooh. Ooh, boy. So now, I'm going to put it over N. We did this one last day. Do you remember we used the sandwich or squeeze theorem? We proved last day that this limit is what?
0.
We proved that this limit is 0.
It's harmonic convergence.
Yeah, it basically is harmonic in nature. Although it's like high, 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 low, 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 high, 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 low, low, but getting smaller because of the divided by n part. The limit does exist. So that means that this sum would be, I'm still adding numbers that are kind of random in nature. I can't tell you what the sum is. In fact, that is the true statement. What's the second piece of the nth term test?
It gets small.
It's got to be smaller than. But
This statement is actually true. Does anybody know how often?
sometimes.
Exactly half the time it's true. And exactly half the time it's false. And even if I put absolute values, it's true half the time and it's false half the time. And it's not very hard for you to find. And it's not true from some point on.
Right.
Because why? Because the signs change, and the fact is the values. The values on top are not getting close to 0. The values on top are bouncing around forever. So I fail this. I'm going to put that. I fail this. Therefore, this diverges. It diverges, you can say, by the nth term test. That, by the way, that's about the worst problem I could think of. Okay, if you give me a few minutes, I might think of one that's worse. But that one's really awful. We don't spend a lot of time on things of that nature, but you got to bring in things of that nature just so you can see how something might not work. In Calc 1, do you remember when you first learned limits, particularly one-sided limits, you often used piecewise functions? Right, that's functions that it looks like this graph for a while, then it looks like this graph, then it looks like this graph, and you looked at the places where the graph changed definition, one-sided limits. You looked at piecewise function because it's a brilliant way to introduce one-sided limits and see, right? But did you ever actually work with them through calculus? No. No, you only use them to talk about continuity and limits. In differential equations, they will become very important in one context way, way, way late in the course. But in general, it was a tool to help you understand continuity and limits. This is a tool to help us understand when things will diverge and things like that. But when we're doing our series come forward, we're not going to be working with transcendental functions in general. No. Just not. They're not going to be useful. So you're not going to see sines and cosines and e's and inverse tans and stuff. You could, but you're not going to. You're going to see quotients of things with exponents and stuff. Because otherwise, we can't really analyze them much. You're going to see exponents. You're going to see factorials. You're even going to see logs. Okay? We can even do that. All right? Any questions? I think I'm actually at a good stopping point. Let's go and do that.